Now let us understand the meaning of angle of intersection of two circles. As shown in the diagram, suppose we have two circles that intersect each other at points P and Q. Now at one of the points of intersection, say at point P, if we draw the tangents to both of the circles, right? So the tangents are shown in green color. So these are the tangents to those circles drawn from the point of intersection. Now the angle between these two tangents, denoted by theta, that is called as the angle of intersection of two circles, right? Now suppose we have to derive the expression or the formula for calculating this theta. If you observe from the plane geometry, we have angle C1 P C2. This particular angle is nothing but pi minus theta, or that is 180 degrees minus theta. So therefore if you consider triangle C1P2 in triangle C1C2, right, we use the cosine rule. And cosine rule states that in any triangle you can get the expression for cosine of one particular angle. So therefore we have cos of pi minus theta that is angle C1P C2, that is given by R1 square plus R2 square minus, let us call the third side, that is C1 C2 side of that particular triangle, as say D. Okay, so let us denote it as D. So we have D square whole divided by 2 R1 R2. Now we know that cos of pi minus theta is minus cos theta. So therefore if we want to consider an acute angle, so we will not write the minus sign and we will consider the absolute value of the expression on the right hand side. So that gives us mod of R1 square plus R2 square minus D square upon 2 R1 R2. So that's the expression for angle of intersection of any two circles. Now as a special case of this is what is called as the orthogonal intersection of two circles. In fact it applies to any two intersecting curves. So by orthogonal intersection of two circles we mean if the angle of intersection of two circles is 90 degrees, then the two circles are said to intersect each other orthogonally. So that means the formula of cos theta will now simplify, because if theta is 90 degrees then cos theta turns out to be 0. So that means the numerator of this particular right hand side has to be 0, and therefore we get R1 square plus R2 square minus D square equal to 0. And if we have the two equations of the two circles in terms of their general form, then finally on substituting we get 2g1 g2 plus 2f1 f2 is equal to c1 plus c2, where g1 f1 and c1 are the parameters in the first equation and g2 f2 and c2 are those in the second equation of the other side. Let's solve one simple question based on this. A circle passes through origin and has the center on line y equal to x. If it cuts the circle x square plus y square minus 4x minus 6y plus 10 equal to 0 orthogonally, find the equation of the circle. Right. Now let us assume the equation of the required circle in the general form, that is x square plus y square plus 2gx plus 2fy plus c is equal to 0. Now since it passes through the point 0, 0 which is origin, it means that the constant term has to be 0, because only then the origin will satisfy the equation of the circle. And also since the center lies on y equal to x, that means the center which is normally given by minus g comma minus f, that turns out to be, we can write that as minus g comma minus g only, because basically both coordinates are the same. Or in other words, we can also assume that g is nothing but equal to f. Right. Now since the required circle cuts the second circle orthogonally, if you remember, we have the condition of orthogonally cutting circles as 2g1 g2 plus 2f1 f2 is equal to c1 plus c2. So therefore 2, we have g1 g2, or if you want we can take, first of all let us take the terms common. So taking 2 common, we have 2g1 g2 plus f1 f2 is equal to c1 plus c2. Therefore 2 into bracket. Now g1 stands for the g term of the first circle, so that we take as just g, and g2 stands for the g term of the second circle. If you observe, the second circle has x coefficient as minus 4, so therefore its g term will be half of that, that is nothing but minus 2, plus once again f1 is the f of the first circle, but since that is equal to g, we can take advantage and write it as g only. Okay. And f2 is the f term of the second circle. Since coefficient of y is minus 6, the f here turns out to be minus 3 is equal to. Now c1 is the constant term of the first circle, and which we have already found out to be 0, and c2 is the constant term of the second circle, that is nothing but 10. So therefore on solving this, we get the value of g to be equal to minus 1. So that means f is also equal to minus 1. So if g and f are minus 1 and minus 1, so basically that gives us the center of the required circle to be equal to negative of those, so that means it is nothing but 1, 1, right? So therefore substituting the values in the original equation, we get the final equation as x square plus y square minus x minus y equal to 0. That's the required circle.